2016 Projectiles, question 3A. This diagram is given, and the question was: a ball is thrown from point A at a target T, which is on horizontal ground. The point A is 17.4 meters vertically above the point O. The ball is thrown from A with speed 25 meters per second at an angle of 30 degrees below the horizontal. The distance OT is 21 meters. The ball misses the target and hits the ground at the point B as shown in the diagram. And the first part of this question, find the time taken for the ball to travel from A to B. So if we look at the initial velocity of this ball, it's going to be 25 is u by the cos of 30, which is the angle in the I direction, and it's going to be plus 25 sine of 30 in the j direction. Cos 30 is root 3 over 2, so 12.5 root 3 times I, and just plus 12.5 times j. The sine of 30 is a half. So if we look at the change in the j direction, the distance traveled in the j direction is 17.4. So we use our s is equal to ut plus a half at squared, and the acceleration is just gravity bringing it down this time. The 17.4 is the distance traveled. The initial velocity in the j direction, we're looking at j here, is 12.5. So we can get the time taken to get there using this, and minus 9.8 over 2, so minus 4.9 t squared. So we're going to have 4.9 t squared minus 12.5 t plus 17.4 equals 0. So again, just type this into your calculator using the quadratic formula and you'll come up with two answers. So one of them is negative and the other one is 1. So it has to be 1. We can't have a negative time. Part 2, we're asked to find the distance TB, this little distance in here. Well, we know the distance OT is 21, so we get the distance OB, which is S of X, or S of I. We use an I here. So the distance traveled in the I direction is just UT, no acceleration. So we're going to have 12.5 root 3 times 1. Pretty straightforward enough, this part. So that's just going to be 21.65. So minus 21 is equal to 0.65 meters. So straightforward enough for the distance TB. Part 3, C is vertically above T. And we're asked to find the speed of the ball. Well, to get the speed of the ball, we're going to need to find the time first. So how far has it traveled? It has traveled 21 in the I direction at this point C. So if we use that information with this formula, we get the time taken to get there. So it's just going to be less than a second. So 21 is the distance traveled in the I direction. That's going to be equal to ut, and we know u is 12.5 root 3 in the I direction times t, and 21 divided by 12.5 root 3 gives an answer of 0.9699 seconds. So now we can get the distance traveled in the j direction. The speed of the ball. So in the j direction, u plus at is going to be my 12.5 plus the acceleration of 9.8 times 0.9699. If I type this into a calculator, it comes out actually quite evenly around 22 ms to the minus 1. So my overall velocity vector at this point is my I 12.5 root 3 and at this point it's traveling at 22 in the j direction. So we've worked out 12.5 root 3 already up here. We multiplied by 1, so we're going to get 21.65 plus 20 in the I plus 22 in the j. So the speed of the vector, the velocity vector at this point is the square root of 21.65 squared plus 22 squared, which gives me 30.87 ms or meters per second.